Hi everyone, it's Mark here from Mark's Trains. Today I thought I'd show you how to convert a Hornby turntable to DCC control. So to start with, I've been in here, pulled a few pieces out already in preparation. So I've removed the two wires from the back of the motor. So that simply just clips in the back. So to remove the motor well housing, place the screwdriver gently on the side. Off it pops and unclicks, but be careful because there's two gears here which will come out. It's not a great deal if it does come out. I use tweezers here to remove them, place them to the side carefully. The motor just literally lifts up out of place. It's held in by two little spring clips in the front and at the back. So what I've done is I've clipped off the capacitors and the wiring for the motor, and I just have standard motor terminals there. Obviously I've cleaned them up with my soldering iron. I'm now going to run a fresh piece of flux solder on the terminal so it's nice and bright. That gives us a good solder joint once it's up and running. So there's the motor. That go in the bin, it's no longer needed. And to replace it I have a short section of wire that's probably about 8 inches long. Obviously it's more than enough to drop it down the baseboard to connect the power supply just for the motor control side of things. We do also have the main input track, so the left and the right hand rail will come in here, two wires run underneath which supplies the turntable rails. As it goes round you have spring loaded clips underneath each rail, so as you go along the power then powers up each rail separately. Although on DCC all these rails around here would be wired up to the DCC power supply. One thing you have to bear in mind though, however, is getting your left hand right hand rails in the correct polarity. The biggest problem with converting these to DCCs is when you use them, you wire up your layout, you end up having a short circuit, so the left and right hand rail crosses over, etc. So it really is best in a way to have at least the outputs from the turntable powered purely by this rail. So yeah, that's my advice to start with. So today we're going to be using a Trainomatic decoder. These are fairly new in stock. This is their mini 8-pin version. So what I've done is I've cut off forward reverse lighting output, function output 1 and the blue common positive. I've snipped them off, place a piece of heat shrink over it, stop it from shorting out. And now I'm going to wire up the motor. So I'll take the orange and the grey motor wires. I'll just trim a little bit of the insulation back. And I always find these locking tweezers are quite handy for doing fiddly work like this. So I'll just basically gather the wire up that's held in place, clean my soldering iron tip, pre-tin it, get some heat on, just dab a little bit of solder on. So they're pre-tinned. Whilst I'm here, I'm going to remove the insulation on the left and right pickup, that's the black and red. Place them on the tweezers. Obviously you've got to be mindful of where this hot soldering iron tip's going. You don't want to end up melting any plastic and such. Next stage, before I actually fit the wire into the motor, I'm just going to trim back the insulation on the track bus pickup wires. Solder these straight onto the decoder first, and I'm going to heat shrink them over so there's no joints sticking out. Everything's all perfectly secure, insulated. Last thing you want is short circuits blowing the decoder. So that's that done. I find these tweezers are quite handy, gives you an extra set of hands basically. Now these wires are only short sections, so I can get away with not putting the heat shrink on first. However, it's worth bearing in mind that if you do have to use heat shrink, a bit of solder on that, if you do use heat shrink, it's probably best putting that on first before you make your solder joint. It's just more the case of when you're working on locomotives. As you can see, I've got a spare piece of wire at the end there where I can slide the heat shrink over. So cut 2 pieces of heat shrink down to size. Roughly 10 millimeters is more than enough for this. That's the red, that's the black. Slide that down. These can be a little bit fiddly to line up, get in the right location. I'll just grab my heat gun. And slowly work my way around. And that there is nice and secure. And now it's for the motor. So the motor is magnetic. You've got to be careful that the soldering iron doesn't hit the motor and stick to it. Be a right pain in the backside getting that soldering tip off. So I've held it in place with a pair of tweezers, stop it rolling around, and I need some heat shrink. This is where it's important. So 2 pieces of heat shrink, one in the orange, this is the right hand terminal, one on the left, which is grey. Obviously the motor, it doesn't matter which way it goes, it'll still work either way. And we just slide our heat shrink over the terminal, keep that isolated. Can be a bit fiddly, but we'll get there. It's a case of persevering. Get my hot air blower again. And that's that, shrunk down. So the motor is now ready to go in. Place the motor down, just slides in. Grab some tissue, got a bit of grease on my fingers. Not a great issue, but it's nice to keep everything clean and tidy. I have a box of these double-sided adhesive foam pads. Place one pad underneath. Peel back that, and then find a nice location for the decoder to sit where it's not going to be in the way. That's a nice area there. Try and persuade these wires back here, hook them back, and now I'm going to tie a knot. This is mostly for strain relief. So the wires are in place. What will happen now is when this is located in this slot here, you pull the wires, it's not going anywhere, it's not going to pull the wires off the decoder, so we'll worry about that last. What we need to do now is get these gears back in. So that pops in down in here, it's located. The next one is the gear that goes onto the worm, that's a cluster gear. And then finally the top gear here, which lines up with a square hole in the drive. Got some grease on the turntable, I'm a messy pup. still it'll be cleaned thoroughly anyway once I'm done, just to make sure these are sat lined up. Place this wire down here, slip it over, and as you can see now, all secure, and that's basically one turntable done. In the next video we'll demonstrate how it all works. I'll see you soon. Hello everyone, and welcome back to part 2 of the Hornby turntable DCC conversion. Now what I've done since the last video is I've stripped the insulation off these two wires and pre-tinned them with solder. So now all I have to do is connect the crocodile clips, ready for a DCC power supply. Now today I'm using the ECOS system by ESU, quite a good controller system, and I've put myself a small Hornby locomotive on the turntable just to demonstrate it moving. And now what this will do, as you can see, it will turn, the rails will line up, and then you can drive your locomotive on and off. The motor's still turning, so as you will see it will line up, it will stop, give you a chance to turn the motor off, like that. That's then held in place, locked in place. If I want to turn it the opposite direction, I can do. This is the advantages of DCC control compared to the Hornby little switch lever they use. They only have a single polarity on that system. Now as you may notice, the track itself is dead, simply because the DCC supply for the motors is separate. The track power, obviously you have your feeding track coming in through here, giving you your left and your right hand rail, whichever way you want to choose. Then two pieces of wire run to the centre for a set of contacts, powers this centre rail up. And obviously these are only powered up when these strips come into contact. Now it is important to stress again that if you're using a DCC system, you can remove these 4 brass copper contacts. So then that would isolate the rails on the turntable, and each output will then be supplied from your droppers, from the outputs from the turntable. But it is important to bear in mind that the rails have their polarity, they're not matched, otherwise you get a short circuit. So what generally happens is, as the locomotive moves off these rails and hits this section here, if this is a left hand rail but this is the left hand rail, and they're basically swapped over, they're crossed over, that will then cause a short and the whole system will get knocked out. So that's something just to bear in mind, that if you do have issues, it's not necessarily the wiring on the turntable, it could be you might have swapped one of the feeder rails. So yeah, that's basically it really. One thing I would suggest is not necessarily whacking up to full speed. I'm doing so now, and you can really hear the motor buzzing away. It's probably not going to do your turntable and gears any good, so I'll keep it at probably about a third speed, which as you'll see it will turn into the next stage in a minute. It's definitely more than enough speed there for it. You don't want it going too fast. So yep, that's it. That's only taken me 10-15 minutes to achieve this. I hope you enjoyed the video. Thank you very much.